All right, now let's touch on tariffs real quick. If the world price is down here and the government taxes on a tariff to that world price, equating to this vertical distance right here, that means that producers are not going to sell this many units, resulting in this triangle right here of producer surplus. Consumers are going to demand this many units, resulting in this triangle here of consumer surplus. And then this rectangle right here is going to be the government's tariff revenue. And this little triangle right here is the production loss, a form of deadweight loss. And this one right here is consumption loss. Let's move into quotas real quick. Their areas actually look pretty similar to tariffs. The only difference being that we're shifting the supply curve to the right by the quota amount instead of tacking on a tariff to all the imports. But at the end of the day, we still operate at an increased quota price. And from here we can start to assemble the tariff-like areas. Producers are outputting this many units, resulting in this area of producer surplus. Consumers are demanding this many units, resulting in this area of consumer surplus. And when we draw the lines down from these points, we can see this rectangle of what's called quota rents. Instead of this being like revenue received by the government, it's increased revenue to foreign producers. And like tariffs, this is the production loss triangle, and this is the consumption loss triangle. If you're working with an externality type problem, look at the intersection of these social curves for the socially optimal point of output. I can tell this is a positive externality because the intersection of the private curves occurs at a lesser quantity. In other words, the private market's outputting this many units, but society wishes they outputted more because there's external benefits falling on third parties, resulting in this triangle right here of welfare loss. Same goes for negative externalities, but it's flipped. This is a socially optimal point of output, but the private market's going to output this many units. So we incur this triangle of welfare loss. If you're working with a Lorenz curve or Gini coefficient type problem, this straight line represents perfect equality of income in this given country. But that's impossible to achieve. So this more curved Lorenz curve represents an actual country's distribution, with a smaller portion of the population holding a majority share of the income. The Gini coefficient of this red country is simply the percentage of area between its Lorenz curve and perfect equality. The smaller that a Gini coefficient is, the closer that a country's income distribution is to perfect equality.